Here is an example of what we call a special SN2 reaction. And you'll see why it's special in just a moment. We're starting with an alcohol. We're reacting it with a hydrogen iodide. It would also work with hydrogen bromide or hydrogen chloride. So we can write here HX, where X is either chlorine, bromine, or iodine. All of those would be acceptable. This particular reaction uses HI. And we're going to form a 1-iodo-butane. This overall reaction will involve an SN2 reaction, but at first glance it looks like that shouldn't be the case. This substrate, for example, looks like it's got a poor leaving group on it. The OH group is a lousy leaving group. And HI is not a recognized nucleophile. Iodide anion, I- is a good nucleophile, but not HI. So how does the reaction occur? Well, it actually occurs in two separate steps. And the first step is going to take care of all the problems we just mentioned. Our alcohol, with this OH group on board, does indeed have serious problems where SN2 reactions are concerned. The OH group is a lousy leaving group. It will never behave as a leaving group in an SN2 reaction just as is. But it's going to react with our strong acid, HI, as a weak base. HI is a strong acid. Alcohol is a weak base. What that means is we're going to have an acid-base reaction. The oxygen is going to be protonated by the strong acid. It's going to literally pluck that proton right off of that strong acid. The two electrons of this iodine-hydrogen bond are going to kick on to the more electronegative iodine, and the result is that we have produced an oxonium ion. So when that oxygen gets protonated, we now have an oxonium ion. Like all oxonium ions, this oxygen has 3 bonds and a lone pair. The oxygen formally owns a total of 5 electrons, should have 6 to be neutral, so it's got a positive charge. At the same moment we produce this oxonium ion, we also produce iodide anion. And it is an excellent nucleophile. Now look carefully at this oxonium ion. There is water. We actually have produced in this one step not only an excellent nucleophile but an excellent leaving group. Water, or at least a good leaving group. Water is a good leaving group. Our nucleophile can come in, displace water as a leaving group. It's this second step right here, which is the SN2 reaction, to give us our organic product plus H2O as a leaving group. So it's a special SN2 reaction. It involves 2 steps. The first is acid-base. The second is the SN2 reaction.